Turn on the video. Okay. Aditya Kush, I'm waiting for you to turn on the video. Yeah. Keep it on now, right? Throughout the session, your video should be on. Yeah. Okay. So today we are going to start with the chapter of equilibrium, right? As planned, we have chapter of equilibrium. Yashita, what do you think? What is the equilibrium? What do you mean by that term equilibrium? Pranav?
So I think it means like balance. Like there is no more change in the system going on.
Mm-hmm.
It's balanced.
Okay.
That's what in physics we do.
Okay. Hmm. Jacob?
Sir, I think it means balanced.
Balanced. Okay. What about Kosh? What do you think?
So yeah, I think it's balance.
Okay. In chemistry, what does it mean? Let us see. I'm sharing my screen with you, right? Once I share my screen, I will not be able to see you, right? But you have to talk to me wherever I will be asking questions, right? Or wherever you have doubt, you can just turn on your audio and ask me. And I will not be able to see your chat also, right? So don't send any chat, just talk to me. Can you see my screen?
Yes, sir.
Right.
Yes, sir.
When you talk about something like chemical reaction, these are of two types. One is a reversible reaction, other is irreversible reaction. Irreversible means once the reactant has got converted into product, the product cannot be converted back to the reactant A. And reversible means A into B and B into A. They are interconvertible into each other. Okay. We say reversible reaction. For example, we have a calcium carbonate, a reversible reaction with its products CaO plus CO2, nitrogen plus hydrogen to form ammonia. It's a reversible reaction. PCl3 plus Cl2 to give PCl5. These are all reversible reactions. Thousands of reactions are there which are reversible in nature. And irreversible are those which once the product are formed, they cannot be reversed back. For example, we have an hydrochloric acid neutralized by a base NaOH. It will form here NaCl plus water. So once the salt is formed, the salt dissolved in water, we cannot get an acid and a base. Or a combustion reaction. Once coal is burnt into carbon dioxide, the carbon dioxide cannot give back the carbon and oxygen. It is irreversible reaction. I have a barium chloride, the precipitation reaction with the silver nitrate. Once the precipitates are formed, the reaction cannot be reversed. So thousands of reactions are there which are irreversible. You got it? What I have taught you now?
Sir.
Right. Note it down, everyone.
Yes, sir.
Right.
Yes, sir.
Now, in this reversible reaction, I'm talking about the reversible reaction, when reactant and products are interconvertible, The two reactions are going on, one in the forward direction, other in the backward direction. A state is achieved when rate of forward reaction becomes equal to rate of backward reaction. That reaction is called as a reversible reaction, and the state is called as a state of equilibrium. Equilibrium means the state of a system when the two phenomena are taking place simultaneously but opposite in direction. That reaction is called as a reversible reaction, and system is at the state of equilibrium. Am I clear?
Yes,
sir.
sir.
Right. So this equilibrium we will be studying into two categories. One is the physical equilibrium and second is the chemical equilibrium. For example, I have a liquid vapor equilibrium. Liquid vapor equilibrium. Here I have a closed container and this is a water in the liquid state. And I have connected here with an instrument known as a manometer. Right? Manometer. These are the molecules that I'm showing in the upper region. These are evaporating. Vapors are formed, and so it may be possible that the first layer is completely evaporated. Slowly and slowly, layer by layer, it keep on evaporating, and the level of the water keep on decreasing. Initially, it was here, now it has come down. But after that point, the level of the water become constant. What does it mean? Has the evaporation stopped?
No, sir.
What is
Yes.
happening?
It's also condensing at the same time.
Yes. So the two phenomena are taking place simultaneously. One is the evaporation, other is the condensation. Two phenomena are taking simultaneously. So we say a rate of forward process is equal to rate for the backward process. Pressure becomes constant here because number of vapors are constant. Amount of liquid is constant. This is an example of a liquid vapor solution. Am I clear? It's a physical equilibrium. Here we do not have any chemical change. Only thing is water into liquid and liquid into vapors. They are interconvertible into each other. Am I clear?
Sir.
Yes, sir.
Now, another example we can talk about is solid solution equilibrium. Here we take up an example. Here is beaker and it is having water, just water. And now I'm adding sugar into it. C12H22O11. Normal sugar in which we have a normal carbon, carbon 12. Right? And I have made a saturated solution. What do you mean by the word saturated solution?
cannot accept. It cannot dissolve more sugar. This
Okay,
water.
it cannot dissolve more sugar. Okay, little bit technically, little bit mistake, but of course you are okay. Now, after this saturated solution, I am adding again sugar, which is yellow in color, which is containing the radioactive carbon. This is the yellow in color. I have added here 20 gram, let it be, additional 20 gram after saturation, right? What we observe after some time, that after some time we have some amount, let it be 10 gram normal sugar and 10 gram yellow color sugar. It means what is happening is the speed at which it is dissolving at the same speed, the crystallization is going on. The dissolved sugar is getting crystallized and the undissolved sugar is getting dissolved. So we can say here rate of dissolution is equal to rate of crystallization. Getting me? This is an example of a example of a what? Physical equilibrium, right? Now I'm giving an example of a chemical equilibrium. I have a calcium carbonate in this tube. Here I have a calcium carbonate, CaCO3. Now connect it with the manometer and start heating from here. When we heat it, this get decomposed to give CaO plus CO2. Initially, the carbon dioxide pushes the piston down and it goes like this. After some time, the level of the mercury in the manometer become constant. It means the speed at which the carbon dioxide is formed, at the same speed it is going in the backward direction. Right? So this is an example of a reversible reaction. Am I clear? Reversible reaction, and the system is in the chemical equilibrium. Chemical change is there and chemical equilibrium is achieved. Am I clear?
Yes, sir.
Right. So write down characteristics of equilibrium. Number one, rate of forward process is equal to rate of the backward process. Rate of forward process is equal to rate of backward process. Number two, all the properties, the physical property which can be measured, their property becomes constant. Means temperature, pressure, volume, concentration, or any such properties which can be measured, that becomes constant. There is no change in the value of the temperature, pressure, and volume, right? Equilibrium can be achieved only in a closed container. Only in a closed container. Concentration of the product to that of reactant is equal to constant value. These are the properties we call it's the properties known as a properties of the equilibrium. And this Kc is called as an equilibrium constant. This is called as an equilibrium constant. Am I clear?
Yes, sir.
Yes, sir.
Now, next write down law of mass action. Suppose I have an A to give B. The rate at which A is converting into B is directly proportional to the concentration of the A is equal to K into A. This K is called rate constant, right? When concentration of the A is taken as a 1, the rate will be equal to K. It means rate constant K is equal to rate constant is equal to rate of reaction when concentration of reactant is taken as a unity. When concentration of reactant is taken as a unity. Am I clear?
Yes, sir.
Now I'm taking another example. When A plus B to give some product, then the rate of reaction is directly proportional to the product of A and B is equal to some constant K A into B. When concentration of A and B are taken as a 1, then rate is equal to some constant K. Am I clear?
Yes, sir.
Yes, sir.
Now, suppose I have A moles of A and B moles of B. Then rate is directly proportional to A to the power A, B to the power B. Rest is all same. Am I clear? Now, A moles of A reacting with the B moles of the B to give C moles of C and D moles of the D. I have a reversible reaction. Rate for the forward process is equal to Kf into A to the power A and B to the power B. And rate for the backward process is equal to Kb into C to the power C and D to the power BD. Is that clear?
Yes, sir.
Now, at the equilibrium, rate of forward is equal to rate for the backward process. So I can say Kf into A to the power A and B to the power B is equal to Kb into C to the power C and D to the power D. I can say Kf upon Kb is equal to C to the power C and D to the power D, and A to the power A and B to the power B. Am I clear?
Yes, sir.
This is
Yes.
called as an equilibrium constant Kc. This is called as the equilibrium constant Kc. Similarly, if all this A, B, C, D are in the vapor phase, let it be they are in the vapor phase, then Kp is equal to pressure. Equilibrium constant in terms of the pressure. Pc to the power C, D to the power D, A to the power A, and B to the power B. So we can represent the equilibrium constant in terms of either in terms of the Kc or in terms of Kb. Am I clear? Now, these two things are related with each other, like Kp is equal to Kc RT to the power delta N. The two are related with this expression Kp is equal to Kc RT to the power delta N. Okay. Now, next write down characteristics of the Kc.
So what is delta N?
Delta N is the change in number of moles. Number of moles of the product minus number of moles of the reactant. Right? Number of moles of the product upon number of moles of reactant. Now write down characteristics of the equilibrium constant Kc. Number one property. This equilibrium constant Kc or Kp, it is a measurement of measurement of extent of reaction. Measurement of extent of reaction means more the value of this equilibrium constant, more it is in the forward direction, more toward the product side. Number two, for a particular reaction, at a particular temperature, at a particular temperature, there is a specific value of equilibrium constant. Suppose I say I have this reaction nitrogen plus hydrogen to give ammonia. Then the Kc is equal to ammonia to the power 2, N2 to the power 1, H to the power 3. This Kc has a specific value 1.2 10 to the power minus 3 at 298 Kelvin. At 298 Kelvin. Am I clear?
Yes, sir.
If reaction is reversed, I'm writing the reverse reaction. If reaction is reversed, the equilibrium constant is inversed. The new equilibrium constant will be 1 upon Kc. The new equilibrium constant is 1 upon Kc. If reaction is reversed, the new equilibrium constant is inversed. Just a minute, I'm stopping sharing for a minute. Till now, any doubt you want to ask?
Sir.
No doubt. Okay.
Sir.
Wait a minute. Yes. Any doubt till now? Kush? Yashita? Anyone having any doubt? Jacob?
No, sir.
No. Okay. I'm sharing my screen again. Next point. Write down. If coefficient of a reaction are multiplied by n factor, new equilibrium constant will be nth power of the previous Kc. Nth power of previous Kc. Nth power of previous Kc. Let us understand here how. Suppose I say I am been given this equation, half mole of N2, 3 mole of H, 3 by 2 moles of H2, and to give 1 mole of ammonia. For this, I have a equilibrium constant Kc. And now I'm multiplying by the whole equation with the 2, N2 plus 3H2, to give 2 ammonia. The new equilibrium constant will be Kc to the power 2. I have multiplied here with the 2, so make it now Kc to the power 2. So the new equilibrium constant will be Kc to the power 2. Am I clear? Fourth, if coefficient of a reaction are divided by nth power, are divided by the nth by n value.
Excuse me, sir.
Yes, please.
Sir, why is it constant Kc2?
I have multiplied this whole equation with the 2. Then I'm getting this equation. This property says if a coefficient of multiplied by the n factor, the new equilibrium constant will be nth power of the previous Kc. Means I have multiplied with the 2, so that should be now multiplied power to the power 2. If I had multiplied with a 3, the new equilibrium constant will be cube of the previous Kc. Right? Now clear? Hello? Okay. If the coefficient are divided by the n factor, new Kc will be nth root of the previous Kc. Means new equilibrium constant will be nth root of the previous Kc. Am I clear? Hello? I stopped sharing for some time.
Yes, sir, can you explain it again?
Okay. Keep on interacting with me, otherwise I think that you have gone. Right? Okay. Suppose I have now this equation. I had divided by this equation by 2. Then only I'm getting this equation. Now this equation will be the nth root of the previous KC. I divide by the 2, so I'll get the square root of the previous KC. If I had divided by the 3, the new equilibrium constant will be cube root of the previous KC, and so on.
Okay, sir.
Understood?
Yes, sir.
Now, next write down Le Chatelier's principle. Read on the statement. If a system at equilibrium is disturbed by change in temperature, pressure, volume, catalyst, addition of inert gas, this equilibrium will shift in that direction which may undo the change imposed. Which may undo the change imposed. Which may undo the change imposed. Understood? Now let us try to understand what does that mean. Suppose I say I have a system at equilibrium A plus B to give C plus D. Then the Kc is equal to C into D upon A into B. Right? C into D upon A into B. There is a particular value of equilibrium constant Kc. Now what I do is I try to disturb this equilibrium by adding A and B. Suppose I add A and B, then what do you find? The Kc value should decrease. Yes or no? Getting me?
Yes, sir.
Yes.
But
Yes.
Kc has a one property. Kc changes only with the change in temperature. It's a property of the equilibrium constant. Vary with change in temperature. It changes with change in temperature. Right? So the Kc value should not decrease. It should come to the original value. This is possible only when this increased value is decreased. And this is possible only direction goes in the forward direction. It means if you increase the reactant concentration, the equilibrium will shift in the forward direction. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly, if you increase the concentration of the products, means C and D, the Kc value should increase, but it will not increase because the Kc value changes only when the temperature changes. It should decrease, and this is possible only when the C and D is getting consumed, so reaction go in the backward direction. It means if you increase the concentration of the products, this equilibrium will shift in backward direction. Am I clear? Kc should remain same. If it is changing mathematically, it's just mathematically only, right? It'll move in that direction which may undo the change imposed. Okay. Now let us see the effect of temperature. Suppose I say I have this reaction N2 plus H2 to give 2 ammonia. Its enthalpy is negative value, minus 92.4 kilojoules. 92.4 kilojoules. Right? This is an exothermic reaction. Forward reaction is exothermic, then backward reaction will be endothermic. And it is a particular value of the temperature. That should remain same. But now, if I increase temperature, the temperature of the system will not change. Temperature of the system will not change. Where will the heat go? When I'm heating it, the temperature should increase, but temperature will practically does not increase. This is because the additional heat that we are giving will be consumed in the endothermic process, and reaction will go in the backward direction, and the additional heat is absorbed. Additional heat is absorbed. So I can say endothermic reactions are favored by high temperature. Are favored by high temperature. Similarly, if I decrease the temperature will not decrease. It will produce energy. It means we can say the exothermic reactions are favored by the low temperature. So in that case, the reaction will go in the forward direction. Am I clear?
Yes, sir.
All right.
Yes, sir.
I'm stopping sharing for a minute. Okay. Yes, Pranav. Any doubt till now?
No, sir.
No. Now, I'm sharing my screen again. Aditya, can you hear me? Okay, I'm discussing this assignment now. For a given equilibrium reaction, increase in temperature will, you tell me now.
Increase the rate of endothermic reaction more than exothermic reaction.
Good, good. Second question. Just a second. I think that's something wrong. Wait a second. हाँ तुम गर्म ले आओ. Work upon this question now.
So it is 1 by Kp square.
1 by Kp square. All of you agree with this answer? What we are doing is, number one, we're going in the backward direction. So 1 upon Kp. And number two, we are multiplying with the 2. So that will not square 1 upon Kp square. Yeah, good. Third question.
So more of NH3 is produced.
Why? This is because inert gas is added at a constant pressure. It means when you're adding inert gas, the volume will increase. If the volume increases, then the equilibrium will shift in that direction. The pressure will decrease, I can say, if I increase the, so it will move towards the more number of moles. So ammonia will go in the backward direction. So less ammonia gas will be produced. Fourth question. Try the fourth question.
So is it low pressure and low temperature?
Of
I
course,
mean high pressure and low.
yes, high pressure and low temperature. A. Because high pressure shift equilibrium towards the less number of moles. Now, next. For the following reaction, which of the following holds good? We know the equation Kp is equal to Kc RT to the power delta N. And you can find that change in number of moles are 0. Both the side, the number of moles are equal. So I can say Kp is equal to Kc. Kp is equal to Kc. Am I clear?
Yes.
Sixth question. Active mass here means molarity. Number of moles dissolved in 1 liter solution. Molarity is equal to what? Number of moles upon volume in liters. Means I can say weight upon molar mass into liters. Weight is equal to 120 grams. Molar mass is 60 into 1. That should come out to be 2. Wrong answer. Options are wrong. Leave it. Seventh question.
Excuse me, sir, what's KP again?
Equilibrium constant in terms of pressure.
The Kp will never have any unit.
Why? Suppose I say I have this reaction. I am writing Kp value. Pressure of ammonia to the power 2. Pressure of nitrogen into pressure of hydrogen to the power 3. So atmosphere square upon atmosphere into atmosphere to the power 3. So atmosphere to the power minus 2 is the unit of the Kp now.
Oh, okay, sir. Sir, then option D is correct when change in moles is equal to 0.
Option
D, last one.
D is the correct answer. Yes. Okay, now come to this question. Yeah, are you working upon this question?
Yes, sir.
Yes, sir.
Should I help you?
So we'll try first.
Okay.
So is the correct answer option D?
Let us see. Wait. Suppose I have this equation. Nitrogen plus hydrogen to give ammonia. Right?
Yes, sir.
Initially we have 1 mole, 3 mole. It was 0. Right? Initially, when time is equal to 0. 1 minus x, 3 minus 3x, and that will be not 2x. Is that okay?
So not 2x.
Because 1 mole of nitrogen gives 2 mole of ammonia. So x will give
Oh,
you how
yes.
much? 2x only.
Yes,
Yes or
sir.
no?
But in the question, I think they said
1, 2, 3 moles are given respectively.
yes, sir.
Okay,
So
okay,
two
okay,
more.
okay. Okay. Fine. 1, 2, 3 moles are already given in the question. Okay. Then it should be 1 minus x, 2 minus 3x, 3 minus 2x. Any such option there?
I think the last one is like that.
3 plus 2x. Yeah.
Yes, sir. That's the option I gave.
Yeah. Okay, you come to the 10th question first.
So it's option A.
How?
So because first they're reversing it,
Hmm,
and after that they're multiplying by 2.
good. 11th question.
So option C.
Yeah, solid do not have any pressure. Yashita, are you getting this?
Yes, sir.
So do liquids have pressure?
No. Pure liquid and pure solid, their pressure is not considered.
Okay, sir.
12th question. I'm waiting for response.
We're still trying.
Okay. Let me know if you need my help. I will help you.
So I'm not getting anything.
Okay. A plus B in equilibrium with the C, 3C. Find the QC value for this reaction quotient value. C to the power 3, A and B. Number of moles are given here. 1, 2 and 4 and 2-liter vessel. Okay, let us solve here. We are given equation A plus B in equilibrium with a 3C, right? And the Kc value is given to us as a 20 value. Okay, this 20 value is given. Check 20. In a
It's a
2-liter,
21.
yeah. In a 2-liter flask, 1, 2 and 4 mole of ABC are there. Means volume is 1 mole, 2 mole, 4 mole. But volume is equal to how much? 2 liters. So the concentration will be this. Concentration means number of moles upon volume. So 1 by 2, 1 and half, and again 2. Find the equilibrium constant in terms of the QC. 3 to the power 3 upon A, B. So 2 to the power 3, 1 by 2 into 1. 6 upon 1 by 2, that will come out to be 12. This QC value is less than the KC value, so equilibrium will move in the forward direction to achieve the state of equilibrium. It means if QC is less than the KC value, this means the equilibrium has not been achieved. So this equilibrium will move in the forward direction. It means that will move towards the right hand side. Am I clear?
Sir.
Yeah. Anything you want to ask?
Can we write it down first?
Yes, sir.
Yeah, I'm showing here. You can note it down. Done.
Nearly.
No. I'm discussing now ionic equilibrium. Equilibrium, but only in case the product and reactant have ions. For example, I have acetic acid. When dissolved in water, it forms acetate ion and hydronium ion. It forms acetate ion and hydronium ion. So there's an equilibrium between the undissociated molecules and the ions. Am I clear? What you're going to teach? What you're going to understand now? There's an equilibrium between the undissociated molecules and its ions. We have a now initial concentration C 0. At equilibrium, alpha is the degree of dissociation. So C alpha will go. And the equilibrium constant is equal to product upon reactant. Acetate ion into hydronium ion upon acetic acid. So it is now equal to C alpha into C alpha upon C1 minus alpha. The C and C cancelled. It is now C alpha square upon 1 minus alpha. Or Kc is equal to now C alpha square. So based upon this, there will be numericals. Am I clear?
So can you please explain this again?
Which part? Is the first
Initial from the initial concentration.
okay, initial concentration C. It means it is not dissociated, so products are equal to 0. If I say alpha is the degree of dissociation, so C minus C alpha will be left. It means C alpha is reacting. If C alpha react, it will form C alpha of the acetate ion and C alpha of the hydronium ion. Rest is equilibrium constant. Kc value. Product upon reactant. Put in the values and solving it. Tell me, where are you stuck?
Now I guess I understand initial one. Now I understand.
Okay. Now, this is an acid. So I'm using a word Ka, A for acid. In case it is a base, I'll be using a word Kb. Right? Kb. For example, I have an ammonium hydroxide and dissociating to give what? Ammonium ion plus HO negative ion. HO negative ion. C 0. C minus C alpha, it will be C alpha, it will be C alpha. Now Kb is equal to C alpha into C alpha into C1 minus alpha. Again, result will come out to be same. This is cancelled. 1 minus alpha, if alpha is 2 less than 1, then the Kb is equal to C alpha square.
So sir, C means like it is not distributed properly, right?
C for concentration. C for concentration. Concentration initially, C for concentration.
So if the NH4 plus and OH minus have initial concentration as some other value, then
No,
at the denominator,
not possible to have another value. It will be 0 only.
oh,
Initial value means what? When ammonium hydroxide has not got dissociated.
oh, okay, sir. Okay,
It
sir.
cannot
So
be
it
any other value.
cannot exist.
So because alpha is more than 1, that's why KB is equal to C alpha squared, right?
Yes.
Okay.
Now, let us discuss about what is an acid and what is a base. Can you tell me what is an acid?
It dissociates in water to form hydronium ion.
Okay. And what is a base?
It dissociates in water to form hydroxide ion.
Good. This theory is known as the RNS theory. Acid is a substance which gives H positive ions in the aqueous medium. Base is a substance which gives OH ions in the aqueous medium. Right?
Yes, sir.
Yes, sir.
But if I say carbon dioxide, it does not have any H positive ion to donate. Still, it is acidic in nature. Calcium oxide does not have any OH ion to donate. Still, it is basic in nature. How are these acidic or basic? The RNS theory cannot explain. So, this is the limitations of the RNS theory. Number one, it cannot explain the acidic or basic nature of those compounds which do not have H or OH in their molecular formula. Which do not have H or OH in their molecular formula. Getting me?
Yes.
Right. Number
Yes,
two,
sir.
if you say acid and base combine to form salt, right? Yes or no?
Yes, sir.
Then
Yes.
CaO plus CO2 to give CaCO3. This is a salt. It means one of them must be acidic, other must be basic. But the theory
Yes.
does not prove why or how any one of them is acidic or basic in nature. So this theory was rejected theory. Now we talk about the next theory, write down Laurie and a Bronsted theory. Laurie and Bronsted theory. Laurie and Bronsted theory. According to Laurie and Bronsted, acid is a substance which donates a proton. Proton means H positive ion. It means I can say the RNS acid and the Laurie Bronsted acid are same. Yes or no?
Yes, sir.
Right?
Yes, sir.
So I can say HCl, HNO3, sulfuric acid, all these are proton donors.
Yes.
Right? So
Yes, sir.
they are RNS acid as well as the Laurie Bronsted acid. But here condition is that they do not require any aqueous medium to donate. right? Does not require any aqueous medium. In the other cases, aqueous medium was required. In the RNA series, aqueous medium was required. Here, aqueous medium is not required. And proton is the one, base is the one which accept a proton. But RNS base is the one which donate OH ion, which furnishes OH ions. Now, suppose I say I have a molecule of ammonia, NH3. We are adding a proton. The lone pair is donated to the proton and it is now accepted here. So I can say ammonia is a Lowry-Bronsted base. Is that clear? Which can accept a proton is a Lowry-Bronsted base. Understood?
Yes, sir.
Right.
Yes.
Yes, sir.
Now, I'm giving you one example here. This is an acetic acid. I'm adding water here. This is a proton donor and water is accepting a proton. So that will form acetate ion. And water is accepting a proton, so that will form an hydronium ion. It becomes positively charged. So this is a Lowry-Bronsted acid and this is Lowry-Bronsted base. The proton acceptor is the Lowry-Bronsted base. And acetic acid is a Lowry-Bronsted acid. And in the backward direction, now see the backward direction. It is just opposite. Now this is giving a proton and the acetate ion is accepting a proton. We call them as a conjugate base. And this is a conjugate acid. Conjugate acid and conjugate base. So how is conjugate base formed? By losing a proton. By losing a proton. And conjugate acid is formed by the gaining a proton. Am I clear?
Yes.
Yes, sir.
Now,
Yes.
I'm now showing you one question here.
So can you give it to copy first? Can I
Sure,
copy that?
sure. Not done.
Excuse me, sir. What's conjugate acid again?
Conjugate acid is formed by gaining a proton. So water accept a proton and become a conjugate acid formed by accepting a proton. And conjugate base is formed by donating a proton.
Okay, sir. I'm done.
Now, let us come to this question now. Wait. Come to number 5, question number 5. Two Bronsted bases in this reactions are
HC2O4 minus and HPO4.
this and this, right? Oh,
Yes, sir.
it means this B option. No, conjugate bases, na?
Bronsted basis. So
A base is the one which accept a proton.
so
So 4 3
PO43 minus and
negative.
C2O42 minus.
Yes, so that should be C option. Okay, now conjugate base of hydrozoic acid. Hydrozoic acid is HN3, right?
Conjugate base is N3 minus.
N3 minus, yeah. Now N3 one negative one. This one. Leave this part. These things I have not taught you yet, but I'm coming to the next topic first. Next, write down Lewis theory of acid and bases. Lewis theory of acid and bases. Just give me a minute. I'm stopping sharing for a minute. Okay. Yes. Till now, any doubt? Pranav?
No, sir.
No. Kush?
No doubt, sir.
Yashita? Jacob?
No, sir.
No, sir.
Okay. Aditya, are you there? Aditya, if you are there, turn on video. Neha, are you there? And camera should be on your face. It is above your head. Okay. Keep it on. And turn off your audio. It is disturbing. Okay. Now I'm sharing my screen again. Write down the Lewis theory. According to Lewis, acid is a substance which accept a pair of electrons. Which accept a pair of electrons. For example, any positively charged species will be attracting electron. So it is a Lewis acid. Cl positive ion, H positive ion, or any other positive charge species like Na positive ion, magnesium ion. All these are right. Secondly, all the electron deficient compound. are electron deficient compounds, are also acids. For example, if I say boron trichloride, it does not have a complete octet. It is an empty p orbital. In those empty p orbital, ammonia is donating electron pair. So I can say ammonia is electron pair donor and BCl3 is electron pair acceptor. Which accept a pair electron is a Lewis acid. And which donate a pair electron is a Lewis base. You can write down Lewis base is a substance which donate a pair of electrons.
So can you repeat the definition?
Write down Lewis acid is a substance which accept a pair of electrons and Lewis base is a substance which donate a pair of electrons. So ammonia here is donating a pair of electrons. So this is a Lewis base. Am I clear?
So Lewis acid accept the electrons.
Yeah.
And Lewis base gives the electrons.
Yeah, donate a pair of electrons. It gives a pair of electrons. Now, based upon this, go to question number 1.
So pH3 acts as a Lewis base
How?
because it gives two of its lone pair electrons
Okay,
to.
so phosphorus is a lone pair electron, right? That can be donated in empty orbital of the boron, right? Okay.
Yes.
Right. Fine. Now, let us come to the next topic. Right on pH. pH is equal to negative logarithm of H positive ion. If upon calculation pH comes out to be less than 7, that solution is acidic in nature. If the pH comes out to be greater than 7, it is basic in nature. If the pH is equal to 7, it is neutral solution. Okay.
Yes.
Now, come to question number 9. The pH of the K2S solution is pH of K2S
More than
solution.
7.
Tell me,
More than 7.
I'm not getting you.
So greater than 7. A.
How can you say that it is greater than 7?
Because potassium is more electropositive.
No. Potassium sulfide, when dissolved in water, I'm making an aqueous solution. It will form here KOH plus H2S. This is a weak acid and this is a strong base. Right? That is why the overall solution is basic solution. And the pH will be greater than 7. Now clear? So it is greater than 7. Any doubt?
So it's greater than 7 because is it weakly acidic? That's why.
It is strong base. Strong base means the pH greater than 7.
Oh, okay.
Now we come to let us now understand the Kw value is equal to hydronium ion concentration into OH ion concentration. That is equal to 10 to the power minus 14 at 298 Kelvin. So I can say in a solution, in neutral solution, hydronium ion is equal to OH ion. In neutral water, both are equal. So I can say hydronium ion concentration square is equal to square root of this 10 to the power minus 7.
So what's Kw?
Ionic product of water. This is called the ionic product of water. Okay. Now coming to the question here. At 90 degrees Celsius, hydronium ion in pure water is 10 to the power minus 6. The Kw value will be. See, the Kw value is equal to nothing but this. So hydronium ion concentration is this. Water is also, OH ion will also be same. So the Kw value will be 10 to the power minus 12. So 10 to the power minus 12. Getting me?
Oh, yes.
Come to question 123. Can you solve this question? pH of 10 to the power minus 3 molar HCl is approximately. You're given the
So
con.
I think the answer would be 10.
Mhm. If your answer comes out to be 10,
So it's
it,
not acidic anymore.
yeah, that will come in the basic range, right?
Is it 1?
Let us see. When I say 10 to the power minus 10 molar, it means it is a highly dilute solution, right? So the hydronium ion that is coming from an HCl, its concentration is 10 to the minus 10. But it is dilute solution means it is dissolved in water, and water is also giving H positive ion. That is giving 10 to the minus 7 molar. It means total H positive ion concentration is equal to coming from the HCl and coming from the water. This plus this. Take it common now. 1 plus 0.001. So 1.001 into 10 to the power minus 7. This. Upon calculation of the pH, put into this formula and solve. This value comes out with 6.93. It was slightly acidic in nature. It's very near to 7, slightly acidic. It does not mean it is neutral. It's slightly acidic, 6.93. So here you have to count the H positive ion coming concentration from the
So what did you ask?
total H positive ion concentration will be equal to H positive ion coming from the acid and coming from the water molecule. Getting me? Note it down.
Yes.
Yes, sir.
So it is 7 approximately. Exact value 6.93. Okay. Come to level 2, question number 1. This one. Try to solve this question. You do it now.
Or 6.95.
See, we have been given, yeah, you're right. You have been given 10 to the power minus 6 molar, right? And now it is diluted 100 times. It means the concentration of the H positive ion will be not decreased by 100 times. Right? It is equal to, if it directly calculate the pH, that will come out to be 8. That is not possible. Right? It means, again, the pH will be slightly less than 7. No need to calculate. We can say it is 6.95. Understood?
Yes, sir.
Right. Let me find out. Let me see some questions here. Okay. Now let us understand next topic now. I'm stopping sharing for a minute. Can all of you hear me? Yashita, Aditya, Kush?
Yes.
Yes.
Alright. Kush, your video is off. Aditya is permanently off. I don't know what. Aditya, are you there? He's not responding. Anyways. Okay. Students, we started the class late by half an hour. Can we continue for another half an hour?
I'm fine, sir.
Everybody? Yashita?
Sir.
Yeah. Okay.
Yes,
Check.
sir.
Okay then. Pranav? Okay, good. Okay, fine. We started late, so let us finish the chapter, right? We have some topic left, and that can be done another half an hour very easily. Okay. Okay, let me know. Are you getting the topic? Understanding it?
Yes, sir.
Yes, sir.
Anyone?
sir.
Anyone having any doubt? Any question? No doubt. Okay. If it is there, you can ask me anytime, right? Okay. The chapter is not difficult, but it requires a little bit mathematical calculation. Little bit, right? It has a lot of simple mathematics. Simple mathematics. It is not higher mathematics. We are not using mathematics of the grade 11, 12. Simple mathematics of multiplication, division, plus minus, right? So not difficult at all. Okay. Now, the next topic I'm going to discuss is can you see my screen?
Yes, sir.
Yeah, yeah.
It is a common ion effect. Common ion effect. This is the acetic acid. And in the aqueous medium, it is not completely dissociated. It is undergoing incomplete dissociation. It is undergoing incomplete dissociation, right? So we say it's a weak acid. Now I'm adding sodium acetate, that's a strong electrolyte, undergoing complete dissociation. But between the two things, there is a one thing common, that is the acetate ion. Can you see that?
Yes.
Due to the common ion, the concentration of the acetate ion will increase here in the equilibrium. And according to Lee Chatelet principle, if you increase the concentration of the product side, the reaction will go in the backward direction. It means its dissociation will further decrease. Its dissociation will further decrease. It's a decrease in the degree of dissociation. Write down. Common ion effect is decrease in degree of dissociation of a weak acid or weak base when a strong electrolyte having a common ion is added to it. Having a common ion is added to it.
So when the concentration increases, the dissociation decreases, right?
Yeah, right. It can be strong, it can be weak acid, or it can be weak base. Here I'm showing only the weak acid. Similarly, I can show it with the weak base also. And now I'm adding ammonium chloride to it. That is a strong electrolyte. It will form ammonium chloride. Now the common ion reaction goes in the backward direction.
So isn't there also reversible?
No.
Okay.
See, the first reaction is reversible. That's why it is going in the backward direction. Weak base is dissociating and it is in equilibrium. Yes or no?
Yes.
This is known as a common ion effect. Any doubt about this? Now, let us go to question number 13 now. Based upon the same concept, let us discuss one question here.
H2S.
Which one?
H2S,
Why?
because it won't disassociate in water unlike the others.
See, understand. I'm coming to the main topic again. It's a decrease in the degree of dissociation of a weak acid or a weak base, right? It means whenever we add an electrolyte to weak acid or weak base, its degree of dissociation decreases, right? But H2SO4 is strong, so it will not affect its degree of dissociation. It is already dissociated. Other three are weak acids. Their degree of dissociation will be affected. Their degree of dissociation will be affected by the HCl. So it will not show the common ion effect with the H2SO4. Am I clear?
Yes.
Now,
Yes.
now let us discuss about the solubility product. Solubility product. I have a salt like AB, potassium chloride, A positive, B negative type. When dissolved in water and made a saturated solution, it forms A positive and B negative. Right? Aqueous solution. Wait, something wrong I have done. First of all, it is dissolving in water. AB aqueous. And now it dissociates to give A positive and B negative. For this equilibrium, I'm writing equilibrium constant A positive, B negative upon AB. A positive, B negative upon AB. Right? This AB will remain constant because it is in saturated solution. So product of these two constants is equal to A positive and a B negative. This is called as a solubility product KSP. A positive and B negative ion. Means basically solubility product tells about the product of the concentration of the ions in the saturated solution when the solution is saturated. Now, S mole per liter is the solubility of the A, and here also S mole per liter of the solution of B. So S into S, or I can say S square, is KSP value.
Sir?
Yeah.
Is AB constant in this?
Yeah, because in the saturated solution, when the saturation there's no change in the concentration of the undissolved this one AB. Every concentration become constant in a state of equilibrium.
Oh, okay, sir.
Yeah. Note it down, all this.
Yes.
Now, if I have a AB2 type of salt, this will dissociate to give it is solid, aqueous. This will form A2 positive and 2B negative. Right? It's a aqueous. Here we have an equilibrium. And now I can write equilibrium constant A2B to the power 2 upon AB2. So K into AB2 is equal to A to the power 2 and B negative power 2. KSP is equal to S into 2S to the power 2. I can say KSP is equal to 4S cube. Am I clear?
Yes.
Why 2s to the power of 2?
Okay. Here we have an S mole per liter, right? And B concentration is 2S mole per liter. So the B I'm putting here 2S, A I'm putting here S to the power 2 by the formula. Got it? Okay. Now let us solve some questions. Number 19. Go for solving number 19 now. No, not 19. Leave it. Yeah. Number 21. Which compound is not soluble in water? That compound will not be soluble whose solubility product is very, very less. So tell me which has the least KSP value that will not be soluble in water. Which has the
So
least KSP?
Bi2s3.
Yes. Now come to number 5th question. Yes. See, PbCl2 it gives Pb2 positive plus 2Cl negative ion. The solubility of PbCl2 in water is 0.1. Its maximum concentration 0.1 mole of NaCl will be. If I dissolve this in water, in NaCl, this is a strong electrolyte and electron go in the backward direction. Right? The concentration due to sodium chloride is 0.1, so the chloride will also be 0.1. But here, this is the PbCl2, 0.01 molar, 0.01 molar. Solubility 0.01, and it is also twice into 0.01, means 0.02. So we should be given here the KSP value, then only we can solve it. Leave this question, not required. Leave it. Okay, come to number 26th question. Check in which case reaction will not go in the backward direction. There its solubility will be maximum.
Pure water.
Pure water, yes, pure water. In rest, all gases reaction go in the backward direction. Okay. And now come to 9th question.
Excuse me, sir.
Yes, please.
So in the previous question, how was it pure water?
See, I'll show you. Just a second. This question, huh?
Yes.
Yeah. Silver carbonate. Its KSP value is very, very less. So it is undergoing incomplete dissociation into its ions. If I add sodium carbonate, this will cause the common ion effect, and reaction goes in the backward direction. Can you see that?
Oh yes. Yes.
If I add silver nitrate, this will give silver ion, again cause the common ion effect.
Yeah.
And if I add potassium carbonate, again the common ion effect.
Yes.
But in pure water, there is no any common ion effect. It may reaction go only in the forward direction. It will have maximum solubility.
Oh, okay, sir. Okay.
Now come to the 9th question.
So they have the same solubilities. So all of the
No. The
constant.
solubility product will depend upon the product of the two ions. Na? These two will have similar because both are giving the same number of
Yes,
ions.
sir.
But here number of ions are more.
So it will be greater.
Yeah. So minimum. KSP value will be minimum.
So why?
KSP is equal to what? Concentration of P Z to the power 3 upon PZ, right?
Yes, sir.
Oh, that should have maximum value. None of this is correct. None of this. It should have been here. Okay. Now come to 15th question here. No, leave it. 19th question.
So how do we know the solubility? What is the solubility they have given?
Hmm. See, MOHX. It will produce MX positive, X moles of OH ions. KSP is equal to MX OH ion to the power X. You have been given the value of the KSP value also. How much? 4 into 10 to the power minus 12. And you are given the solubility 10 to the power how much? Minus 14. And 10 to the power minus 14 to the power X. Find the value of X. Can you work upon it? Calculating?
Yes, sir. The solubility means the number of moles of MOHX.
Mm-hmm.
I'm not getting any answers still.
I'm stopping sharing for some time. You have the result that you have to calculate.
Yes.
Answer comes out to be here 3 actually. You try to solve it. Right? You'll get it. It's not a big deal. Get it.
Okay, sir.
Okay. Remaining question I'm sending, you can do it because some questions we have left, right? You can do it. Otherwise, we can discuss in our next class also. Okay. Okay,
Yes,
then
sir.
I'm ending session now. See you next week. Same
Thank
time.
you, sir.
Okay.
Yes, sir.
Thank you, sir.
Okay. बस तूने मेरे को मैसेज भेजा कोई?
हाँ वो प्रिंट आउट निकालना है।